Good morning all of you. Welcome to ABN and BRR College online classes. Today we are going to discuss Cosets and continuation part. In the last class we discussed about the result is any two right cosets are identical if and only if A dot B inverse is an element of subgroup. Okay. Today another result is that if H is a subgroup of G and A and B are two elements of group, then part 1 is about if A is an element of another coset generated by B, that is HB, if and only if two right cosets, that is generated by A and generated by B, are identical. Similarly, in the case of left cosets, that is A is an element of left coset generated by B, if and only if both the left cosets AH and BH are identical. Okay. Given hypothesis is that G is a group and H is a subgroup and A and B are two elements. Let us consider them as a hypothesis. G is an group with the identity element is E and HB any subgroup of G. It is a subgroup. We can write cosets for only subgroups. That's why H is any subgroup. And given that in the hypothesis A and B are the two elements of G. So, let us consider A and B are the two elements. Regarding to these two elements, we can write two left cosets as well as two right cosets. We will prove this theorem according to right cosets. So, I can write here two right cosets generated by A and generated by B. The coset generated by A is HA. Those elements are nothing but X dot A, where X's are nothing but subgroup elements. Similarly, HB, that is the coset generated by B, right coset, especially right coset generated by B is in the form of consisting composite elements Y dot B, where Y's are nothing but subgroup elements, two right cosets here. Let us prove this theorem. I can prove only part 1, similarly you can prove second part 2. Okay. Coming to the part 2, we have to prove that A is an element of the coset generated by B if and only if two cosets are identical. So, in this case, we have in this part 1, we have two cases because it is a necessary and sufficient condition. The case 1 is assume that A is particular element A is an element of coset generated by B. This is the assumption. What is our claim in this case? We have to prove that those cosets generated by A, nothing but right cosets here, generated by A and the right coset generated by B are identical. For that, we have the assumption. Let us use the assumption. Since A is an element of coset generated by B, all the elements of coset generated by B are of the form Y dot B, like that. So, A is of the form A is equal to some Y into B, where Y is an element of subgroup, isn't it? Because the elements in the coset generated by B are of the form Y dot B. Okay, right. That implies A into post multiplying with B inverse on both sides, we have like this, by post multiplication with post multiply with B inverse on both sides. Left hand side treated same, but on the right hand side use associative property. We can write like this, by associative property. What is the value of B into B inverse? By using inverse property, this value is identity. What is Y dot E value? This is nothing but Y, because E is identity. Okay. Now observe that where is Y? Y is our subgroup element. Where is Y? Y is our subgroup element. So, it is an element of our subgroup. Now using transitivity, A dot B inverse is nothing but an element of H. A dot B inverse is nothing but an element of subgroup H. That implies by using last class result, whenever A dot B inverse is an element of subgroup, we can write cosets generated by A and B are identical by the result 1. Result 1 in the last lecture. What are we have to prove here? We have to prove that cosets are identical. Already proved. In this case, proof is over. Consider second case. What is the second case assumption? Assume that cosets are identical. Now, to prove that A is an element of coset generated by B. Clearly, we can write A is E dot A, where E is the element of subgroup. You know that identity element in the group and subgroup are same. Where is this E? This is a subgroup element. Now observe that the A is a composite element like a subgroup element into A, that is the right multiple of A. That means it is an element of coset generated by A. Therefore, A is an element of coset generated by A. Here we assumed that the coset generated by A is identically equivalent to coset generated by B. That implies using transitivity, you can easily say that A is an element of coset generated by B. This is our claim in this case, hence the proof. Thank you.